Hello, in this video we're going to talk about topic 3.7 of the AP Chemistry curriculum, solutions and mixtures. So, if you recall, matter is divided into two big categories, pure substances, and pure substances only have one type of particle making them up, such as elements, which have only one type of atom, or compounds, which have one type of molecular formula unit. The other type of matter is mixtures. And there's two different types of mixtures. There's homogeneous and heterogeneous mixtures. Homogeneous and heterogeneous mixtures. So homogeneous mixtures are mixtures that are consistent in their composition on a macroscopic scale. In other words, if you look at a homogeneous mixture, you can identify the different parts of the mixture. In fact, you may confuse it with a pure substance, but there are indeed two or more different substances mixed with one another in a homogeneous mixture. Heterogeneous, there is not a consistent composition on a macroscopic scale, so you can identify the different parts of the mixture very easily. We are going to focus in on homogeneous mixtures, which sometimes are also called solutions, or solutions are also sometimes called homogeneous mixtures. So solutions can be solid, liquid, or gas. So you can have a solid solution. Alloys are a good example of a solid solution. So like a penny is made out of zinc and copper. That's an alloy. Brass is made out of zinc and copper, and so you can have a solid alloy. I'm pretty sure I messed that up, but anyway, let's move on. You can have liquid solutions. Rubbing alcohol is a great example of that, where you have the alcohol and water mixed together and you can't identify the different parts. And then you can also have gaseous solutions like air, where you have different elements that are all mixed together and you can't identify the different parts. So we're going to talk about one unit of concentration of solutions that we've used throughout the semester or throughout the year, and that's molarity. If you recall, molarity is given the symbol capital M, and molarity of a solution is equal to the moles of the solute divided by the liters of the solution. In other words, the moles of what's dissolved, the part that's dissolved, divided by the entire solution, the liters of the entire solution. So with molarity, we can actually start representing or figuring out how much of something is dissolved in a particular volume of solution. So I got an example here where we are going to calculate the molarity of a sodium chloride solution, where I have 35 grams of sodium chloride that are dissolved to make 250 milliliters of solution. So if we're going to calculate the molarity, we need to know the moles of solute, and we need to know solute divided by the liters of the total solution. So if we look at the problem, we have the milliliters of solution, which we can easily convert to liters of solution, but we don't have the moles of solute. The moles of solute is not given to us. We're given grams of solute. So we're first going to have to convert our grams to moles, then we can calculate the molarity. So let's go ahead and do that real quick. So we have 35.0 grams of sodium chloride, and according to the molar mass, for every 58.44 grams of sodium chloride, there is 1 mole of sodium chloride. So this will give us the number of moles of sodium chloride present in the solution, which is 0.599 moles. Now you'll want to leave the entire number on your calculator, but I'm rounding it here just for ease. Okay, so now to calculate the molarity, we're simply going to plug in our moles, 0.599 moles, and we're going to divide that by the total volume of the solution, which is 0.250 liters, because we moved the decimal over 3 places to get liters from milliliters. So when you do that, you should end up with 2.40 molar, and the capital M is pronounced molar. So that's how we can calculate the molarity of the solution. We simply need the moles of the solute, and we also need the liters of the solution. So how can we use this on a more practical level? Well, let's look at another example problem where I have a solution of copper sulfate, and I want to find out how many grams of copper sulfate are in this solution. So if you look at our problem, we have 1.50 liters of a 2.4 molar copper 2 sulfate solution. Now, one thing to remember, when you're given the molarity of the solution, this is actually a nice conversion factor. We know that there's 2.40 moles of copper 2 sulfate. Copper 2 sulfate for every 1 liter of copper 2 sulfate. So molarity can actually be used as a conversion factor between moles and liters of the solution. So that's one important thing to remember about molarity, is that it allows you to convert between moles and liters of a solution. So we're going to be going from 1.5 liters, we'll convert liters into moles, and then using the molar mass or molecular weight, we can convert from moles to grams. So let's see how we're going to do this. We're going to start with the amount of solution we're given, 1.5 liters of copper 2 sulfate. According to the molarity, for every 1 liter of copper 2 sulfate, there are 2.4 moles of copper 2 sulfate. So for every 1 liter, there's 2.40 moles. So at this point, our liters have been transformed into moles. And so we'll figure out how many moles are actually dissolved in 1.5 liters. But we don't want moles, we want grams. So we're going to convert our moles into grams using the molar mass. Up here we have the molar mass. 1 mole of copper 2 sulfate is 159.609 grams of copper 2 sulfate. Moles cancel, and we're left with grams. Now, I've given you the molar mass, but you definitely wouldn't have to be given that. You may have to solve for that on your own. Go to the periodic table and add up copper and sulfur and 4 oxygens to get the molar mass of copper 2 sulfate. So if you do this math, multiply across the top, divide by the bottom, you end up with 575 grams of copper 2 sulfate. So this calculation is a calculation that I do all the time in lab when I make solutions for the labs that we do. I have to figure out how many grams of a solute would I need in order to make this volume of this concentration solution. So this is a very common calculation that you would do, and one that you should be very familiar with, because you will definitely need to do a calculation on the AP test like this. If you have any questions about this, please let me know. I'll be happy to help you out. Good luck with your studies.